What I am going to be talking about is what is this pre-post disturbance vegetation type layer. This is something new that is being developed to feed into the excellent introduction that Jim did on this new tool to potentially be used for LANDFIRE updates. So I'm going to talk about work that was done prior to me on the development, some testing and validation that I'm going to be focused on, briefly touch on the application that Jim has already talked about, and then some things that have arisen as we, I say, as Sky and Leonardo and other people who are not me implemented that. Background, so again, Jim has given my background already. But LANDFIRE was created to provide these landscape scale layers, right, to support cross-boundary management planning and operations. And there are always ongoing updates, not just the annual updates, but again, updates as in developing these new layers that might serve us a little bit better. And so with this PDVT layer, the goal, the motivation was to provide 30-meter resolution product that had relatively stable site conditions that was useful for modeling and predicting these short-term 1 to 30-year changes in fuel and vegetation. And the motivation here was that the existing site potential layers that LANDFIRE had developed were not working as well for modeling current and time disturbance outcomes into the future as Wendell thought they should be. These were sort of mapped when LANDFIRE started with the best available data at the time, of course, and that included like temperature and precip data that was at quarter-kilometer resolution. And so this created a sort of shadow effect on the 30-meter vegetation layers that caused some splintering of existing vegetation types and sort of rolling downhill issues that we are hoping something like this layer might help to rectify in order to build on. So I'm going to walk quickly through some steps on the creation of sort of this first iteration of PDVT. You're welcome to ask difficult questions about it at the end, and I will make Wendell answer all of them. So it started out with a combine of LANDFIRE existing vegetation type modeled, EVTM, with the remap existing vegetation type. And EVTM was developed by, I believe, Darren. And what that layer did was replaced all of the recently disturbed types that exist in the LANDFIRE layers with the vegetation type that would have been there without disturbance. So to go through and get rid of areas that were just mapped as recently disturbed forest and replace it with the actual forest type. And then assigned attributes to each of those combinations. The majority of those attributes inherited from the sort of the BPS model, and assigned those areas that are replacing the recently disturbed types to the appropriate existing vegetation type fuel. And then went through and grouped tree, shrub, or herb types with similar geographic areas within geographic areas and vegetation names into a PDVT type, and coded that PDVT in a sequential way. So if there was a tree type, it got the tree type. If there was no tree type, it got the shrub type. And if there was no tree or shrub, it got the herbaceous type. And really the main driver here, again, was to retain that scale of 30 meters and not cause any additional slivers or splintering of the existing vegetation classification. So we're grouping here only when it's on similar sites with similar response potentials to time and disturbance. But we are grouping, again, in order to sort of undo some of that slivering and splintering that exists in the current layers. Ooh, I hit the forward button one too many times. Then we step into cross-checking the PDVT groupings with our fuel groupings. In most cases, they followed a similar grouping. And then we go into those, again, those recently disturbed types that have to be filled in and coded those based on their modeled assignment of which they should, of what their vegetation type would be. And then, of course, go in and review as necessary the natural wildland and anthropogenic types to evaluate if similar ones were occurring on similar sites and grouping those that had ancillary site information to be able to test and see if those could be grouped together. Oh, okay. I don't know how a duplicate slide ended up in there. Okay. So the testing and validation step. What we are doing now that Wendell has created this sort of first iteration, right? Now we can go in and look at the PDVT groupings to ensure that we haven't overgrouped, and then to see places that, you know, that we might need to split additional ones. So particularly in some of the developed areas that might still burn and might still have disturbance, seeing where we might need to go in and piece some of those out. Data that we're going to be pulling from is including the LANDFIRE slope aspect and elevation, pulling in climate data, and then again that plot level data that we don't necessarily have our hands on quite yet, which is why this is still in the I don't have results to share from the validation. Also because I had a hard drive crash, perfectly timed immediately before this presentation was put together. But analyses to include things like ordination, cluster analysis, multi-permutation procedure, to be able to describe the site conditions of the PDVTs and also the spread of site conditions within PDVTs, to see whether some PDVTs are covering maybe too broad an ecological range. Again, because this is being built to model off of. So if we have ones that are too broad, it's not going to be as useful for modeling 1 to 30 years into the future. And then the application. So this is being fed into that tool that Jim talked about as the ecological stratification. And as Apex has started to develop this tool, we found a need for implementing some hierarchical groupings. So again, based on the data, the plot level data that we have available, some of these vegetation disturbance combinations do not have sufficient data to develop these growth response curves. So this is one particular example, Wichita naviculite glade and woodland, which is a ridgetop forest type in bits of Arkansas and Oklahoma that I'm probably not even pronouncing correctly. from this particular data set, we have an N of 1, which is not quite enough plots to develop a growth response curve. But if we can group it into post-oak, woodland, and savanna, then voila, we do have enough to develop a curve. And so that has been something that I've been working on. And so I based those mostly on existing LANDFIRE, existing vegetation fuels groups. And where possible, I kept them in those groups because those are already set and validated. I did go in and already preemptively group a lot of the agricultural types. So, like there's a whole bunch of, hay is separate from row vegetation and blah, 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 blah. I grouped those into herbaceous and non-herbaceous. Some of them were lacking existing fuels, and I went in and created groups for those to mimic that existing fuels convention, some of the developed area types. And then some of them insisted on being difficult, and even at the end of all that, there were orphan ones that were still not grouped, so really unique types. And those I went in and combined based on geographic similarity, dominant, codominant species, and a general description based on the NatureServe ecosystem descriptions. And here you can see, so this is an area in central Appalachia with a lot of agriculture types. And you can see a lot of those get grouped, subsumed in together, as expected. And then this is on the eastern corner of the Snake River Plain in Idaho. Again, we have a bunch of agriculture types, but also a couple of different big sagebrush types that get grouped in together. And so what this did was it condensed our 678 PDVT types down into 105 level 1 groups. And this is just an example. So Atlantic dunes and grasslands has something like 6 of them that got subsumed into this group. And so based on some of the preliminary modeling results, and again, you can ask difficult questions about this and I will make Sky answer them. A full modeling run for a single map zone, there was really good coverage using just the PDVT and level 1 groups. And then for full CONUS, trying to see if we had the plot data to develop those cover types. It was about a 50-50 split of ones that PDVT had enough and then ones that we needed the level 1 groupings to get adequate data for a growth curve. Next step, level 2 hierarchical groups. Some of them insist on being difficult, and so we need more groups, and also to update some rules for certain combinations that are going to perpetually lack data. So if we're trying to model a disturbance type in a vegetation type where that disturbance really doesn't happen very often, we're going to have to create rules to say, like, we're not going to model that disturbance type here. And then based on the testing and validation of this first iteration of PDVT, creating a PDVT version 2 to have and to be available. So if I have time, we would love to have questions, comments. This is a layer that its goal is to be used for modeling. And so with a captive audience of modeling people, we would love feedback and comments as we develop this.